Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No, we've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry, we'll be here next Wednesday night as well. So bring those questions with you if you want, and you can ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hello, everybody. Welcome to Wednesday night math night. Like Dr. A said, I am one of the math specialists here, and I absolutely love spending my Wednesday nights with you guys, just working through some math problems that are really going to help you prepare for your exam. Now, like he said, this is not a comprehensive exam review. This is 10 questions that I've pulled or that I've created that are going to range from pre-K through 12. So this is not something that you're gonna, be able to use for your entire exam prep, but it certainly gets the ball rolling. I love catering these sessions for you. So if there is anything that you want to see me go over in the coming weeks, please don't hesitate to ask in the comments or find me on Facebook. You can send me problems. You can send me concepts. You can comment below. But if you're like, I'm really struggling with geometry, I'm really struggling with coordinate grids, I'm really struggling with X, Y, and Z, that's what I need help with. I am more than happy to add that to sessions coming up. But before we get started, I always like to know who's in the room. So in the comment box, let me know where you're from, what test you're prepping for, and are you a potato or a sweet potato person? I know that there are some diehard sweet potato people out there, but there are some people who would much rather a normal potato. I don't know why I thought of that question. I like to get to know the people in the room, and I have potatoes sitting on my counter. We like an equal share of potatoes and sweet potatoes in our house. But all that said, I really do like to know what test you're prepping for because it helps me guide our conversations. So let me know in the comments where you're from, what test are you prepping for, and are you a potato or a sweet potato person? I am from Central Florida. I am an assistant principal in Central Florida with my certification in K-12 mathematics. So you can definitely say that math is one of my favorites. TExES EC6, awesome. The GK, fantastic. Hey, Joseph, good to see you again. I love seeing familiar faces. All right, let's go ahead and get started with our first problem for tonight. What is, oh, it would help if I made this bigger. What is the value of x if the perimeter of the shape shown below is 60? So this is very similar to a problem we did last week. It, with the exception of last week, it said, what is the perimeter of the shape? But in this case, they are saying, what is the value of x? So if they said, what is the perimeter, we would add up all the sides of our shape. But they're asking us what the value of x is. Now, when I say we would add up all the sides of the shape, we need to make sure that we're adding this side, which is this side, which is this side, which is this side, which is this, but that we don't stop there, that we keep going with this side and this side, even though we don't know what those are. And we're going to talk about how to find those here in a minute. We did this last week a little bit, but I like to show you that they can take one problem and ask 1,000 questions about it. So this one diagram, we can ask a lot of different questions about it. So what they're telling us is that the perimeter is 60. Perimeter equals 60. That means when I add up all my sides, I'm going to get 60. So let's start by adding the sides that we do know. 4 plus x plus 1 plus x plus 11 plus 2x plus 6. Hey, Hope, it's good to see you. Hey, Milagros, it's good to see you too. I will get back to you on that question about last week. I don't want to go backwards to go forwards, but I will get back to you on that question. So these are the sides that we have. I have this plus this plus this plus this plus blank for this side plus blank for this side, and I'm going to run out of room, so I'm going to go ahead and move this down here. All of that equals 60. Now, I can't move forward without figuring out what those boxes are. I could simplify all of this a little bit, but then after that, I would get stuck. So I have to figure out what is this and what is this. Now, this can be confusing for some people, especially because we have variables. However, what I need you to understand, now this kind of shape is definitely going to be seen on an elementary or an EC6 exam. The part that makes this above an elementary or an EC6 is the fact that we have variables. Most of the time on an EC6 or an elementary, you're not going to see this problem written with variables. You're going to see this problem that looks more like this. I don't know why I put 12 there. That would not make sense. And then you would have to find the perimeter if, or they might say find, yeah, they might say find the perimeter, because then you can find these two sides. Now I'm going to show you how to find those two sides. This whole side right here is x plus 11. If I go from the tippity top to the tippity bottom. How do I know that? Because these are all 90-degree angles, which tells me that if I closed this shape off, I would create a rectangle and opposite sides are equal. Are you following? So if opposite sides are equal, then I know that that whole thing is x plus 11. I also know that this chunk right here is 4. So if the whole thing is 11 and this chunk is 4, I can do the whole minus the part. Let's think about a part-part-whole diagram. Elementary people, you should absolutely know what a part-part-whole diagram looks like and how students use it to solve. So for a part-part-whole, I have a part plus a part equals a whole. Yes? So my whole is x plus 11 in this case. But I might have a whole, if I wanted to use real numbers, I could have a whole of 15, and then part of it would be 8. Then the other part would be 7, because 8 plus 7 is 15. I know that in my head. However, For this part whole, I have part of it is 4, but I don't have the other part. What do I have to do to find the other part when I have a part whole? Well, I can subtract the whole minus the part, and it's going to equal the other part. If I had the two parts, then I can add part A plus part B, and it gives me my whole. So I can do x plus 11 minus 4. 11 minus 4 is 7. So this piece right here is x plus 7. Agree? Now I'm going to use that same exact process for this side. And I'm going to change colors because I don't want us to get muddled. So this whole side is 2x plus 6. If I use a part whole diagram, 2x plus 6 is my whole. What is my part? Because I'm trying to find this section right here. My part is x plus 1. That part plus this part is going to give me 2x plus 6. So I have 2x plus 6 minus x plus 1 as a chunk. And I have to remember that that's a whole chunk because it's minus the whole thing. The number one mistake people are going to make on this problem is people are going to write minus x plus 1, and it's going to be plus 1. So I have 2x plus 6 minus x minus 1 because that negative distributes. 2x minus x equals x. 6 minus 1 equals a positive 5. So this is x plus 5 because this is x plus 5. All right. Now what I'm going to do is simplify all of this. So I'm going to find all my x terms, and I'm going to combine them. 1, 2, 3, 4, 5, 6 x's plus, oh, what did I just do? There we go. Plus 4 plus 1 plus 11 plus 6 plus 7 plus 5. I'm going to use my calculator for that. That way I don't get confused. So 4 plus 1 plus 11 plus 6 plus 7 plus 5. That's 34 equals 60. Then I'm going to go ahead and solve this like an algebra problem. Subtract 34 from both sides. 60 minus 34 equals 26. So I have 6x plus equals 26. Divide by 6 on both sides. X equals 4.3 repeating, which is C. Where do I get the 2, the 9, and the 14 from? This was a made-up problem. This was me showing what kind of problem could be seen on an elementary exam without variables. And why is it x plus 7? Because I took this as my whole and subtracted my part, which is 4. So x plus 11 minus 4 is x plus 7. All right, let's move on to the next problem if there's no more questions. All right, same exact shape, different problem. What is the area of the shape below? So this is a critical problem for everybody. More for my elementary people, definitely more for my elementary people, which includes my GK people, because GK math is really 4th through 8th grade math. But everybody really needs to know how to solve this problem. Everybody needs to understand composite shapes. So when we look at this problem, I immediately see a shape that I don't have a formula for. I know the area of a rectangle equals length times width. But is this a rectangle? It is not a rectangle. So I'm not going to do length times width. So I'm not going to do 24 times 14, because 24 times 14 would be the area of this shape right here. That is not the shape we have. All of this is missing. So I'm going to tell you, you have a choice in this matter. You can solve this problem by doing addition or subtraction, whichever one you prefer. So you could split this shape up. So option 1. Cut it, add part A plus part B. And it just disconnected. I have yet to figure out why it did that. So I could do A plus B. Or I can do the area of the whole rectangle. I could do the area of the whole rectangle. And then subtract out this piece. 2 options on how to solve it. I prefer A plus B. That's just the way I usually solve composite area. You can solve it however you want. So if you're thinking I'm going to solve it using subtraction, run with it. And then we can compare answers. Can you get me some water? So is it because 4 sides of a square? I'm not so sure what your question is, so ask it again and I'll be more than happy to answer. So that said, I'm going to cut this shape right here. Now, could you cut it a different way? Absolutely. You could cut it right here if you wanted. Either way works. It doesn't matter where you cut it. You're still going to get the same answer. Like I said, I usually cut it like this. It's just what I'm used to. So if I cut it like that, I've created an orange rectangle right here, which has a length of 14 and a width of 5. So I'm going to do 14 times 5. And that's going to give me, thank you, 70. Then I'm going to find the area of this rectangle right here. But that's a little harder because I don't have this side or this side, because this whole thing is 24 and this whole thing is 14. So I have to solve for my 2 sides. On question 1, I'll go back to it. So how am I going to do that? The exact same way we did it on here. The exact same way we did it on here. A whole and a part and a part. So I'm going to take my whole, which is 24, and then I know that part of my whole is 5. So my other part is going to be 24 minus 5. 24 minus 5 is 19. And that makes sense because 19 plus 5 is going to give me a whole length of 24. So this side right here is 19, which means this side is 19. I'm going to do the same process with the number 14. I'm going to have a part whole. And my part whole is 14 is my whole. But what is my part? What is my part? And it's trying to reconnect. There we go. So if my whole is 14, what is my part? My part is 4. So then 14 minus 4 is 10, which tells me that this is 10. 19 times 10 equals 190. And then I add those 2 values together. 190 plus 70 equals 260. Excellent job, Hope. Excellent job. I'm still not understanding your question, Milagros, because this question is very similar to this question. You said, is it because it's 4 sides of a square? I did not talk about squares at all in this problem. So whatever you're asking, it is not because it's 4 sides of a square. All right, problem number 4. 2 rectangles are drawn in the coordinate plane. This problem is for whoever my friend was that asked for a coordinate plane problem. Someone asked for a coordinate plane problem, and this is that problem for you. So 2 rectangles are drawn in a coordinate plane. I am a very visual person. As soon as I see that, I am going to draw a very fast coordinate plane so that I can sketch what this looks like. I may not use the sketch for anything other than visualization, but that is such an important piece of this when we're solving problems. So 2 rectangles are drawn in the coordinate plane. The vertices of the first rectangle are, I'm going to highlight the first rectangle in blue because I'm going to do all of these points in blue. So -4, +1. So someone specifically asked for problems in coordinate plane, so I'm going to go back to the bare basics of coordinate plane. Graphing on a coordinate plane, very quick review. This is the x-axis, this is the y-axis. I am going to jump. This way is positive, this way is negative. Why? Because that's how a number line operates. So I go right to go positive, I go left to go negative, I go down negative, up positive. So keep that in mind as we're solving this problem. I always do the X before the Y because the X is first in the alphabet. So this goes first, then this goes next. So -4 is going to go first. 1, 2, 1, 2, 3, 4, up +1. I'm going to erase that so we can see where our point is, but I'm going to go over -4 to the left, up 1. I'm going to go -1, up 1. So there's my other point. I'm going to go -1, down 4. 1, 2, 3, 4. That's right here. And I'm going to go -4, -4. There's my rectangle. The vertices of the second rectangle are these. So over 1, up 2, right 1, up 2. Oop, that's not a pen. Over 6, up 2. So right 6, up 2. Over 1, up 5. 1, 2, 3, 4, 5. Find the value of X and Y that allow these 2 rectangles to be congruent. What does congruent mean? Equal. So if I connect these dots, it does not create a rectangle. If I were to connect them, it would create a triangle. How could I make this a congruent rectangle? Some of you may say they're not congruent. They are. This rectangle is flipped and turned from the other rectangle. So if these were going to be congruent rectangles, I would need a point right here. How do I know those are congruent? Because this side equals a value of 1, 2, 3, and this side equals a value of 1, 2, 3. This side equals a value of 1, 2, 3, 4, 5. This side equals a value of 1, 2, 3, 4, 5. So they are congruent. But what does that mean this point is right here? Well, some of you are better at visualizing this than others. And if you don't draw your graph extremely explicit and accurate, it's going to make it very hard for you to figure out or evaluate what that point is. If we were to zoom in, that point looks like it's at 1, 2, 3, 4, 5, 6, over 6, up 1, 2, 3, 4, 5. That indeed is an answer choice. However, if you got something like 6, 4 or 5, 4, when you look at your answer choices, those wouldn't be answer choices. I know that it's not going to be -4 something, because -4 something would be over here somewhere, and that's not anywhere close to that dot. So at least I could eliminate 2 of my answer choices out of the 4. However, sometimes those answer choices are going to be really close. So how can you look at these? Now, I'm a drawer, but I want to show you how you can look. How can I look at these to figure out what my other point would be? Well, a rectangle, the way these rectangles are drawn when I quickly sketched it, one dot is on top of another. It's not like a catty corner rectangle that looks something like this, where we would have to do like all sorts of angle measurements and stuff. They're right on top of one another. So with that said, I know that I have an X value of 1 and X value of 1. I know I have an X value of 6, so I have to have another X value of 6 because it's a rectangle. And vice versa. I know I have a Y value of 2, Y value of 2, Y value of 5. What does that mean? This has to be a Y value of 5 because they're sitting right on top of one another. Okay. All right, let's keep going. A rectangle is drawn in the coordinate plane. Another coordinate plane question, because this is something someone asked for. So again, as we are working together, I really want you to consider what you need help with. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I realized I didn't need to go to 7 because all of my points are less than 7. A rectangle is drawn in the coordinate plane. 3 of the vertices of the rectangle are -4, 1, -1, 1, and -1, -4. What is the area of the rectangle? So I am going to go ahead and draw this because it's going to allow me to find the area very quickly. So I'm going to go left 4, up 1. That is the 3rd time it's happened tonight. Normally it doesn't happen that many times. I'm going to go left 4, up 1 on my coordinate plane, and I'm going to plot that point. Left 4, up 1 is right there. Then I'm going to go left 1, up 1. Then I'm going to go left 1, down 4. And what is the value of my other point? Well, I can see that this is creating a rectangle where it's stacked on top of one another. So I can go ahead and fill in this other point right here, because that would make it a rectangle. What is the area? Well, let's remember that area equals length times width. So all I need is the length and the width. Now again, this gets real tricky if you did not draw your graph accurately. What is the distance between this point and this point? 1 hop, 2 hops, 3 hops. What's the distance between this point and this point? 1, 2, 3, 4, 5. So area equals 3 times 5, which is 15. So my answer is A. However, what if the rectangle looked something like this? How would you find the area then? Because I can't just count my hops now. I would have to use the distance formula. And the distance formula says the square root of x minus x squared plus y minus y squared. Now, you're going to often see this formula written something like this. Does it matter if you do the second x first or the first x first? No, it does not. It's not going to change your answer. However, it will change your answer if you don't do corresponding X's and Y's first. So if you do the second X first, you have to do the second Y first. Or if you do the first X first, you have to do the first Y first. That's the only thing that that's saying. You don't have to memorize those little 2's and those little 1's if it bogs up your memory. So all that said, I would have to do the distance formula from here to here, and then also the distance formula from here to here to be able to find my area. In this case, we didn't have to do that, but in a case where the rectangle is tilted, we would have to. What is the volume of the figure that would be created from the net shown to the right? So let's remember that perimeter. Hey, Arlene, excellent question. I love when people submit problems. So I can't add them in tonight. We're gonna go off of a little soapbox here. I'll come back to this problem. I can't add them in tonight unless you submit them, like, unless we run out of problems, really, which doesn't usually happen. But if you either type the problem in the comments, I will take it and solve it next week. Or if it's too hard to type because it has math term, like squared, square roots, a picture, whatever, you can send it to me via Facebook. You can find me on Facebook, Amy Sink, and you can send me a message there. And if you don't have Facebook, then I can give you my email address. Am I going to do 3rd through 6th grade math tonight? I have hit on a few 3rd through 6th grade math problems. So like this problem right here was 1,000% 3rd through 6th grade. So every night I do, or every Wednesday I do a variety of problems. So we will hit on another grade 3 through 6 problem here. Actually, another couple grade 3 through 6 problems. So we go grade 3 through 6 all the way through 12th grade. So the one I'm about to do is definitely going to be more middle school and high school. But we do a little bit of everything because we do have people in here doing GK. We have people in here doing middle school and high school. So we do a little bit of everything. All right. So great, Arlene. Awesome. I will gladly look at that and add it to some upcoming weeks for sure. Thanks for asking. That was a great question. All right. So let's consider. Now, Donna, I am going to say every problem that I do, I try to tie in elementary, middle school, and high school concepts. So the one I'm doing right now is definitely more a middle school or high school problem. However, what I'm about to talk about, area of a rectangle, perimeter, area, volume, like those concepts are definitely for elementary people. So my high school people probably don't need me to review perimeter, area, and volume vocabulary. However, I do it for my other people in the room. So I definitely try to like span every problem as far as I can. So let's review. Perimeter is the linear distance around a shape. Area is the square distance inside a shape. And volume is the cubic measurement in a 3D shape. So this is a net, which means it's the flat version of a 3D shape. So if we were to fold this up, we would create a 3D shape. What 3D shape would this create? A cylinder. So everybody needs to know that this would create a cylinder. Finding the volume of the cylinder is definitely not for everybody. Volume of a cylinder is going to be pi r squared times h. How do I know that? Because that just seems like another volume formula to memorize. when we talk about area, or when we talk about volume of prisms, the volume of a prism is area of the base times the height of the shape. What is this right here? It's the area of a circle. All this is a prism formula with a circle. A cylinder is like a circular prism. So we have the area of our base times the height of our shape, which is the distance between the two bases. Now, here's the tricky part with this problem, finding the area of that circle. So what I want you to do is think about this. We know the height. The height is 15 because it's the distance between my two circles, right? So volume equals pi times r squared times 15. The only thing I'm missing is r. What does this value represent in this problem? How is that value going to help us solve this problem? 24 is the circumference of our circle. How do I know that? Because when I wrap that piece of paper around, like if I imagined that that big rectangle was a piece of paper and I wrapped it around and it met exactly perfectly edge to edge, it's going to go around that circle, which is the circumference, the perimeter of a circle. So that said, if I know my circumference equals 24, and I know the circumference formula is 2 times pi times r, then I can set those two things equal to each other, solve for r, plug r in, bada bing, bada boom, we've got an answer. Do I provide the problems I work out with the steps? Are you saying, like, do I provide a PDF of like all of my work like this? Is that what you're asking for? Clarify it and then I can answer the question. So 24 circumference equals 2 times pi times r. Now, I am not going to plug in 3.14 for pi. Why? Because when I look at my answer choices, all of my answer choices have pi as part of the answer. So because of that, because pi is a part of the answer, I'm going to leave the infinite value of pi, 3.14, blah, 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 as pi. So I'm going to divide both sides by 2 pi. So r equals 24 divided by 2 is 12 divided by pi. Now I'm going to plug that value back into my r to find my volume. So volume equals pi times 12 divided by pi squared times 15. I'm going to finish this up here. Volume equals pi times 12 divided by pi times 12 divided by pi times 15, because 12 divided by pi squared is 12 divided by pi times 12 divided by pi. 1 pi cancels with 1 pi. So V equals 144 divided by pi times 15. 144 times 15 equals 2,160 divided by pi. How did I get 12 times 12 is 144? Oh, because when I solved this earlier today, I totally forgot to multiply it times 15. So that said, we're going to just do this kind of number and say that our answer is indeed 2,160 divided by pi. And there's our answer. Any questions about that? Dolores, no, I do not. I say usually, I forget. So you guys have to remind me. We usually post a link to the problems blank, but we do not post the PDF of the problems with the work. But these live sessions are posted on YouTube, so you can go back and watch them at any time you want to review. It's always good to watch them live because you can ask any questions that you want. But you can always go back and watch them recorded, and resolve these problems like by clicking pause or whatever. All right, problem number 7. Suppose two coordinates, A and B, lie on the xy plane. If the coordinates of A and B are -3, 5 and 6, -7 respectively, then what is the distance from A to B and back? Round your answer to the nearest hundredth. So again, a coordinate plane problem where we've got -3, +5, and we've got 6, -7. So I always like to graph it because I want to see if I can quickly, easily count the distance. Unfortunately, this distance is going to be really difficult to count hops. So in this case, I'm going to have to use the distance formula. Now, let's pretend the distance formula is really kind of foreign to you and you don't understand how to use it. Could you sit here and attempt to count spaces? You could. Will you get an accurate answer? Likely not. However, if you were running out of time and you didn't remember the distance formula and you didn't know how to solve using the distance formula, would that be a way that you could find an estimate? Sure, absolutely. Is it going to give you an accurate answer? Probably not, but it might give you a ballpark that you could at least X out an answer or two. But that said, that's not what we're in the business for. We're in the business for getting problems right. So distance equals, we actually talked about the distance formula a little bit ago. Distance equals the square root of x minus x squared plus y minus y squared. Does it matter which one I do first? No, just as long as the x that I use first goes with the y that I use first. So this is going to equal the square root of, I'm going to start with -3. -3 minus 6. I am not going to do -3 minus 5 because -3 minus 5 would be an x and a y, and we're doing x minus x. Plus, now because I did the -3 first, I have to do the 5 first. 5 minus -7. That's going to be where many people make their mistake, is they're not going to do 5 minus negative. So I have the square root. -3 minus 6 is -9 squared. Plus 5 minus -7 makes a big addition sign. So 5 minus -7 equals 12 squared. And then I have the square root of 9 squared is 81. 12 squared is 144. And when I add those two things together, I get 225. And the square root of 225 is 15. That is not our answer, though. Why is that not our answer? Because the question says, what is the distance from A to B and back? So I'm going from here to here and back again. So it's going to be 15 plus 15, which is 30. All right, any questions about that problem? Let's keep going. This is a perfect elementary problem. Reading graphs and interpreting it. And this is going to be where we stop. And then I actually have we're not going to be able to get through all 4 problems that I have today. So I've got some probability for next week, and I have another elementary problem that we will kick off and start with. So the graph to the right shows the temperature of an area over the course of time. So I'm going to stop there and quickly look at my graph. I'm going to take 10 seconds to look at my graph when I'm taking this test, just so that I understand what the graph is saying before I know what the question is saying. So temperature of an area. Here's my temperatures. Here's my time. Almost always your time will sit on your x-axis. So at 8:30, our temperature is 29 point something. At 9 o'clock, it's just over 30. At 9:30, it's right at 30.5. At 10 o'clock, it's at 30.8. What we really want to do is look at our intervals. So down here, we're jumping by half hours. And right here, we're jumping by half degrees. If you don't notice that, that is going to be a critical downfall when you're interpreting data. A lot of times people assume that each line equals 1. But in this case, each line equals a half of a temperature or a half of a degree. So this is 30. This is 30.5. This is 31. Let's look at the question. At what time was the temperature the lowest? So I'm literally going to look at the lowest point of my graph. The lowest point of my graph is actually going to be right at 8:30. How do I know that? Because it's sitting below this 30 line, and I'm going to stretch this 30 line all the way across. See, even these 2 dots don't dip below that 30 line. So at 8:30, our temperature is the lowest. But let's go ahead and look at another problem about the same graph. Again, the graph to the right shows the temperature of an area over the course of time. What is the range in temperatures from 10:30 to 1:30? So the range, and this is not only helpful in data analysis, but it's helpful when we're looking at central means of tendency. The range is the difference between the highest and lowest temperature. The difference between the highest and the lowest temperature. Now, in this case, range is looking for the range between 10:30 and 1:30. So we're not looking at the difference in the highest and lowest when we're looking at central means of tendency, but we're looking at the difference between 10:30 and 1:30. So that's the definition of range when you're looking at data. The definition for this is the difference between your 10:30 temperature and your 1:30 temperature. 10:30 is the 1, 2, 3, 4, 5th data point. 1, 2, 3, 4, 5. So it's this data point right here. And 1:30 is going to be this temperature right here. So what are those 2 temperatures? Let's erase it and see. So this temperature right here is going to be just above the 31, but not even halfway to 31.5. So just above 31 might be 31.1. Because halfway between 31 and 31.5 is 31.25. How do I know that? Because if I think about it in money terms, I have half a dollar or I have a quarter of a dollar. That's kind of where my brain goes when I think about decimals. Now let's go ahead and look at this high point right here. What point is going to be right here? That's going to be about 32.25. So if I subtract 32.25 minus 31.1, I'm going to get 1.15. Now, what answer is that closest to? 1 degree. Because now this is okay. Because they didn't give us explicit numbers to work with, our answer very well might be a 10th, a 100th of a decimal off. As long as we are not incredibly off, it's not that big of a deal. Let's go ahead and look at the next problem. This is the elementary problem I didn't think we would have time for, but we do have time for it, so we're going to go ahead and do it right now. Below is an example of a student's work. This is a classic elementary problem. Below is an example of student work. 5/8 minus 3/4 equals 2/8. 6/12 plus 4/10 equals 10/12. 7/8 minus 4/5 equals 3/8. If the student continues to make the same error, what is the student's most likely answer to the problem? 11/15 minus 3/5 would be what? So they are already telling us that this student is making an error. What is the student doing to get these answer choices? What is the student doing to get those answer choices? They're certainly not getting common denominators, I can tell you that right now. How did they get 2? They did 5 minus 3. How did they get 10? They did 6 plus 4. How did they get 3? They did 7 minus 4. All right, we kind of have an idea. So then if I look at this, then 11 minus 3 would be what? 8. So it's not A and it's not D. Because remember, we're trying to make the same error that this student made. But then when we look at the denominators, we have 8, 12, and 8. Where did they get 8, 12, and 8? Eight, 12, 8. They just took the first denominator they saw. That's all they did. They literally took the first denominator they saw and used it as their denominator. That person would definitely need a small group for subtracting fractions, wouldn't they? All right. We have run out of time because I have to turn it back over to Dr. A. However, in the comments, please let me know what you want to see me work on in the upcoming weeks. Priya and I are going to kind of be sharing the rest of the month of January, and she is amazing. So you will get to work with her a little bit this month too. But if you have questions that you want to see, or you have concepts that you want to see me go over in the coming weeks, please drop them in the comments. If you have specific questions you want to see me solve, please let me know via Facebook Messenger. I'm more than happy to include those in upcoming weeks. So with that said, I'm going to turn it back over to Dr. A. I hope that you guys have a great rest of the week, a great long weekend, and I will see you soon.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. It doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SYNC35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.